Muted. There we go. All right, that's better. Hello, everybody, and welcome to the stream. I hope everybody is doing well tonight. Tonight we are picking up where we left off last week, which is sort of in the middle of our giant sort of refactor effort, and we are debugging our way through, fixing issues as we find them, kind of stitching things back together, and hopefully get this thing running sometime soon. So that's what's on the agenda tonight. Lou the Coder, how's it going? Good to see you over there on the YouTube side. Nothing to see. I could barely read your name, but I was able to parse that. Hello, how's it going over there on the YouTube side as well? I was official over on the Twitch side. Hello, how are you doing? I am well. All right, so speaking of that, before I jump into the meat and potatoes of the stream, I do want to take a quick second and just thank the supporters of the channel, starting with our partners, who are the highest tier of subscription over on YouTube memberships as well as Patreon. They are Dustin Punt, Gebby Bashir, and Gerboles Inc. I would also like to thank all the other supporters listed here on the screen. They are a combination of the other tiers of support over on Patreon, YouTube memberships, and Twitch subscriptions. Thank you all very much for your support. It helps me out a lot, means a lot, and you guys are helping me grow the channel. I hope it goes without saying that I also appreciate each and every one of you, whether you are on the YouTube side or the Twitch side. We do simulcast to both. I do watch both chats. So this is an interactive stream, and I like interacting with you guys. So feel free to jump in if you have anything that you want to talk about that's loosely related to the stream. And, if you have any questions, comments, anything like that, and I will answer them to the best of my ability. Favorite refactoring streamer? Yeah, it is a little bit like that, right? Definitely seems that way. But yeah, this is the unfortunate reality sometimes. Sometimes you just kind of get down the road and you're like, you know what, this architecture isn't going to work. We need to rethink this, right? And in our case, it wasn't really just one thing that we were sort of redoing. We're sort of redoing a lot of items that came up in technical debt. So we've got quite a list of things. I can only imagine what the final pull request for this version is going to look like. It's going to be impressive to say the least. I do wonder if we've actually added more or deleted more code, to be completely honest. All right. Sakelos Music, good to see you. Hello. Welcome to the stream. Singy, good to see you as well. When will macOS get some love too? Yes. So, speaking of that, so we have actually done all of the refactoring needed for the Windows platform and the Linux platform. But what we're going to do is, I think a majority of those things was handled sort of off screen at that level. So what I'm going to do is one of these streams, once we get everything working for both Windows and Linux, which I think should basically happen at the same time now, then what we're going to do is we're going to go back before we merge this version in and get everything working on Mac OS too. So that is going to be interesting because I've never streamed from the Mac as locally on it before. So we are going to do that as well at some point once we sort of tie up all the loose ends. I want to get it working on one platform first. Ideally, it'll work on Windows and Linux at the same time. And then once we switch to Mac, the only thing we have to do is the platform-specific stuff, and it should work there too. So that's kind of the goal. And the reason I'm doing it that way is because while we are sort of troubleshooting all of the graphics engine portion of it, there is always the risk that we actually crash the graphics driver because Vulkan is that low level, right? It's actually possible to do that. And I don't want to take down the stream with it if that happens, right? So we do stream from the Mac. We just input one of the monitors from my PC into that to keep those things separated. So once I have all of that worked out, then we'll go ahead and we'll tie up all of the Mac stuff from the Mac on stream. So I hope that answers that question. Okay, so where we left off last time was I think we were looking at our standard UI controls, and it looks like we've got some of our renderable stuff in here, right? That just needs to be sort of saved off. And I believe this is going to be, these are probably going to be a matter of removing, I think, just the geometry and replacing it with vertex data, element count, right? And just using that sort of new structure that we have in place. And so we're going to have vertex data element size there for the vertex element size. And then the buffer offset is going to be vertex data. And then, let's see, buffer offset. And let's see, do we actually set... We don't actually need the data for that because it's already loaded in the actual vertex buffer, right? So those are the only things we have to set there. This is going to be index data, element count. This is going to be index data, element size, and index data buffer offset. Right, so that fixes that. The only other thing that we have here is the material. And this is, I don't completely remember if we even use the material in here. I don't think we do. I'm not sure why we were doing this. So what I'm going to do is I'm going to leave that as a null and put a fix me here, just so I can come back to it later. And let's see, do we need material here? And we can revisit that later if need be. Okay, so that looks like all the errors for this file, so let's build. SUI button has got the same thing going on. So we'll head over there to that. And in fact, I think it's almost going to wind up being like the same code. So I'm actually just going to take this section right here. It was SUI button. And let's come down here. Yeah, it's pretty much the same thing, right? So I'm actually going to do this, right? So we don't need material. We've copied that over. Vertex count, element size, all the way down to model. Right? Get rid of that. Okay. So that should be it for that. What did we do? We branched this off of vertex data elements. All right, so let's do that here too. And I think that's it for that file. Okay, so we built. Let's go ahead and run. See how far we get. Okay, so let's change this to terminal. All right, so that's something we're going to have to resolve, is received window resize event for a non-registered window. We'll have to fix that. Did we get anything else up here? Just a couple of free lists for really small buffers. Unused outputs. Okay. So I don't think... Okay, so it doesn't look like we got any errors before this, which is good. We actually also got past the memory report stage, which is also good. So let's find out why we are segfaulting here. So we have context current window that does exist. The window internal exists, right? Window renderer state. The backend states, that does not look valid to me. Okay. So what we're trying to do is we are trying to pull graphics command buffers. Yeah, this doesn't exist. So why is that? Why is the address of that 0x1? That's really strange. So let's see how we got here. All right, render frame command list begin. Okay, so we're starting to record the command list. This is like at the very beginning of the frame. This is after we've actually performed updates for that loop. Prepared window surface. Okay. So what is actually... So I guess we need to look at the window creation code to see what is going on here. Because I'm pretty sure graphics pipeline created. So like our shaders loaded correctly. We should also have vertex fragments. Okay, so there's more of that. There's our render graph. Here's our default textures. So did we... Vulkan renderer initial. Okay, so creating Vulkan surface for window. Here we go. Here's where our window creation is. So we got all the way to creating a surface for the window. We've got command buffers. Depth buffer. So if that was all creating successfully, then what happened? Yeah, this is like completely invalid data here. This window backend here. The window internal is also just not. That's not valid data. Okay. Let's take a look at the current window. Yeah, that's not valid either. Okay, so context current window apparently is being set to rubbish. So let's have a look at where that gets set, which would be here. And let's go from there. All right, so I'm going to restart this. All right, so this is where that gets set. Now this looks valid to me. This is valid, right? We've got platform states. We've got a renderer state here. We have a backend state, which looks mostly valid. Yep, okay, so it's valid at this point. So where did this come from? Right, so on window created, engine create. Oh, I see what we did. A dummy move is what we've done. Do you guys see the problem? I see the problem. Let me catch up with chat. Lou the coder. While going through the code, I stumbled upon Xform. What is that? Mind giving a brief on what it's used for? Sure. So that was actually one of the things that we refactored. So an Xform is basically the same thing as a transform, except it works hand in hand with a system. And that system is it works in cahoots with our new handle system to allow us to have handles to xforms. And that allows us to be able to make hierarchies of transforms without having to maintain pointers all over the place. All we have to do is maintain handles to them all over the place. And I called it xform to separate it from transform while I'm transitioning everything over to that new system. Once everything is using the new xforms, I'm going to get rid of transform and then rename xform back to transform. So I hope that makes sense. It's kind of like a temporary name for it. Spiro, how's it going, buddy? I like the dance emotes there. I love it. All right, Dr. Elliott, how's it going? Good to see you. Should have used Rust. No, definitely not. Something is trashing memory afterwards. Yeah, it's me trashing memory and being stupid. I'm sure you probably see it in here, what I'm doing wrong. Good to see you, by the way, Psycode. Okay, so what is ampersand ... pointer? So you're talking about... Where was that? I think it was further down. I think it might have been... Where was that? Let me tell you what I'll do. I'm going to set a breakpoint here, and then I'm going to continue the app to where it crashed. Right? So you're asking about this, where we have the ampersand here and the arrow operator here, right? Okay. So what this is doing is this is saying, okay, this window backend right here is a pointer to a window renderer backend state structure, right? So we're saying, okay, within that pointer, we need the graphic command buffer at this index, which is held in the window backend image index, right? So this is a number, and it's an index into the graphics command buffers array, right? So we say, okay, give me the graphics command buffers at sub whatever this is, let's say 0, right? And then we want the address of that. And so that gives us a pointer to that command buffer. That's what that's doing. So it's kind of a compound of things going on in one line. I could have separated it out, but yeah. I hope that makes sense. The Abdullah, thank you for the follow. Appreciate that. Welcome. Yep, Psycode, you called it exactly. So that was the dumb move that I make, right? So a new window is on the stack here, right? It gets pushed to the D array here, right? But what I'm doing is I'm passing the address of new window, which is only on the stack at this point, is not actually added to this array. And when we push to this array, it actually takes a copy of that memory. So you were kind of right before where it's getting trashed, right? But it's getting trashed because this variable is going out of scope. Didn't think about that when I wrote that. I was probably tired when I did it. All right, so we need engine C, and I think it was like around 300. Right? So what we're doing is we're creating this new window, right? Which we probably shouldn't even be doing this, right? We should probably actually push it to this array first and then do the thing, right? Really before we do much of anything to it. I mean, I suppose we could take this, right? So let's do this. Right, we'll push it here. And then what we can do is instead of taking the address of new window, we'll do a k window what do I want to call this? I guess I could just call it window, right? I don't think I actually have window here anywhere. All right, let's call it window. So we'll say k window pointer window equals, and what we're going to do is say engine state windows And then we need the last index that we just pushed. So we need darray length engine state windows -1, right? And I guess we could wrap this in parentheses just to be extra super safe, right? And then we want the address of that, right? And then instead of passing the address of new window, we just pass window. And then here we do the same thing, right? So this is just going to be window. And that should resolve that issue. Let's see. So it's not just on the Windows backend. Yeah, Zaka has said exactly what he said. It's a unary operator, so it acts on the entire expression to the right. So it's basically the last thing on that line that gets processed. Yep. It's a bit weird if you're not familiar. I've been confused by that before. Yeah. So sometimes, yeah, exactly like Cycode says, sometimes people will just wrap it in parentheses. I suppose I could have done that. Yeah, exactly. It's preference. The operator precedence already treats it correctly, which is why it works, right? I mean, I guess once you've done it enough times, you can just kind of look at the line of code and figure that out, right? You can just kind of figure out what this is doing, right? But if you really wanted to make it more clear, you could do that. And that's perfectly valid too. To me, that's a little bit more noisy, so I usually don't do that, but it's preference. All right, so let's go ahead and build that. And we'll run this again. Oh, I have breakpoints here I don't need anymore. Get rid of that one too. All right, cool. So we got further. Active viewport set. Cool. So I'm going to guess we're getting null here. Yep. All right. So let's see. What is being a bananas here? Internal data VP. Okay, why is that a null pointer? In fact, why is that a pointer to anything at all? That should probably just be a regular structure, and we should be passing the address of this. Okay, so this is UI render graph node. Let's take a look at that real quick, because that just doesn't seem... It doesn't seem completely necessary. So in the internal data, yeah, we do have a... Oh. I have a struct tag here, so I probably forward declared it. Maybe not. Why are we using a pointer to that? That doesn't really make any sense. Incomplete type, okay. Yeah, we don't want to do that. So render types. Where did we actually declare that again? I forget. There it is. Render a viewport H. Okay. This is another structure I am not 100% sold on, as far as like us actually needing it. I might wind up getting rid of that, but for now I'm just going to say render viewport H. I'll just include that just to get around this issue. Render viewport H. All right. So now we can pass the address of this guy. And let's see, that's just the deprecation. That's just the deprecation. Okay, here we go. So UI render graph node, set viewport in matrices. Oh, I probably did that so I could forward declare this, which is kind of dumb now that I look at it. Let's not do that. Right, and then let's go to UI render graph node. Right, that's probably because. So we don't need this. Yes, that's going to require us to have another include, but I think I'm fine with that. That should probably be like in our renderer types as opposed to like its own type, I guess. So this is like another thing that I think I want to rethink. But I'm going to leave it as is because we have enough going on in this refactor. All right. Let's see. What if the array length is 0? Does it crash? Yeah, I mean, technically, I guess it would, right? But that would also mean that we have no windows. So at that point, I guess we won't really be doing much of anything anyways because we need a current window, right? Which actually is going to be a design issue when we go to do like mobile, because mobile doesn't have windows. So we are going to have to revisit that at some point. Let's see. Hi, can you tell me where I can find good resources on PBR rendering? I mean, shader stuff and light calculation, not base of OpenGL or other graphics API. A good resource is see if I can get it in frame here. Real-time rendering. Let me see. This is a pretty good book. It's a chunk, right? It's pretty thick. That's at least 2C thick. I don't think it's quite 3C thick, but you know, it's thicker than a bowl of oatmeal for sure. But yeah, it's a really good book on a bunch of rendering techniques for sure. What is KAPI defined as? So it's an import or an export, depending on what platform you're targeting and what is using it, whether it's a shared library or an executable that we're compiling. So it's right. So it's either for Visual Studio, it's like a decal spec DLL export if we're building a library, or if we're building a executable, it's a decal spec DLL import. Or if you're using GCC or Clang, or basically anything else, right, that it sets the visibility of that. And what that basically means is that when we're building this library, for example, it makes sure that this symbol here is visible outside the library and actually can be imported. Let's see. Just wanted to say hi and love the way you write C. You've inspired me to create beautiful things. Awesome. Glad to hear it. Okay, let's see. pbrbook.org. Yes, that's another good one. Yep, I forgot about that one. I always forget to mention that one. Let's see. I was wondering if you have a tutorial on using CMake for Vulkan. I do not, because I don't personally use CMake. I try to avoid it at all costs, personally. What specific is there for Vulkan? Let's see. How do you include it in the project? Same as any other stuff. Yeah, I mean, we just set our link directory and our include directory, and that's just how we roll. Which right now we're actually statically linking it, which is not ideal. We need to change it to dynamically linked, but that requires a little bit more work. Mostly just raw include it when I use OpenGL. Exactly. Yep. Tell the guy on YouTube to also watch SIGGRAPH basic physically based rendering shading on YouTube. Yeah. I think I know which video you're talking about too. Oh, we have ads. All right, so let me just paste this over on the YouTube side. Let's see. There's a suggestion from somebody on Twitch. All right. Oh boy. Okay, I have lots of chat to catch up on. I should probably pause for a minute and do that once we get back from ads. All right, almost done with ads. Okay, cool. Ads are done. So, let's see. Wise words avoid CMake, yeah. Watch many SIGGRAPH talks, but I don't think I've watched Sucker Punches yet. Supposedly that's a good one. I haven't watched it either. It's in my watch list. I've heard Vulk is good for that. So, if this were a production project, I probably would use Vulk. But what I'm trying to do is eliminate as many dependencies as possible in this project. So I won't be doing that. Instead, I will be doing it the hard, old-fashioned way when we actually do it. Simply because, we want to show how all this stuff works under the hood. But yes, otherwise I would do that. It's kind of similar to using Glad for OpenGL. I have a question. How am I able to include UniSTD and use USleep, for example, on Windows? I think NGW does include that, but I think we actually use the Windows versions of timing functions instead. So we actually don't do that. Let's see. Not entirely relevant, but I see your profile picture on Twitch. Is the beard as a result of the time you spent working on the engine? I wish I could say that, but honestly, if my beard were started to be grown out at the time I started the engine, it would probably be like all the way down to my belt line by now, I would imagine. This is about, I don't know, maybe 8 or 10 months worth. So not quite. But yeah, good question. Do you plan on supporting mobile given you're using a render graph instead of a JIT sync method? Yes, I am planning on supporting mobile. However, rendering pipelines are so vastly different in their requirements for mobile that I'm going to make those backends separately. So we'll have like a Vulkan backend for like desktops, but we're going to have like a separate Vulkan backend for mobile. That's going to be implemented a lot differently. Do you plan on... Wait, nope, I already answered that one. Let's see. The whole series on Ghosts of Tsushima is amazing. I'm using some of those techniques on my renderer, like dynamic specular probes. Yeah, I want to watch that series, actually. That's another one that I just haven't had the time to watch, frankly. First time chat, Doos, how's it going? Came from Java, so I use CMake, VC package, and CLion. Have a pretty Gradle-like experience, pretty nice for dependency management, but there's a lot of overhead, and that's why I don't like it, right? There's a lot of mental overhead with it as well. I'm going to save that link that you dropped. Your beta is so good on you. I appreciate that. Thank you. All right. So, with all that, the Unwise Wolf, how's it going? Good to see you. I think we're finally caught up on chat. Cool. All right. So, where were we? So we were working through this viewport stuff, which I think that's going to be an issue because we're not actually calling that, which is going to have to be done at some point, but we'll see. All right, let's go to go ahead and run this. Okay, cool. We have some Vulkan issues here. All right, so this is not surprising given what we were just talking about. So we have begin rendering. It's interesting that it stopped here. VK command set viewport. Okay. So that could have been from freaking anywhere. So it looks like we've started to execute our render graph. And let's see, we got VK command set viewport width is 0. It's not greater than 0. Gee, I wonder. Why would that be an issue? Okay, so I guess we need to find, since that's likely an issue with this, if I had to guess. I guess really what we need to do wait a minute. Did that? Render active viewport set. So I guess we should probably put a breakpoint here and figure out what is actually causing that to be set to 0. I'll bet it's the UI system. Yep. Okay, so that's interesting. What that means is we got through actually quite a few of our render graph nodes execution-wise. So that's interesting. Of course, it doesn't mean that we actually set stuff up correctly, I guess, but it looks like, yeah, UI is, I think, the last thing to be drawn. So, all right, so internal data VP is not set, which is not terribly surprising. So what we need to do is we need a way to get our viewport. And I'm trying to remember exactly how we were doing that before. I want to say that we generated one ahead of time. And then when we resized, we regenerated the viewport. So let's have a look at UI render graph node. Do we have, so there's the execution, load resources. So we should probably initialize this to something, right? Even if that something isn't actually valid by the time we get here, at least we'll have something, right? So let's do, let's split view here, and we'll go to viewport H, and we have viewport create. which actually we haven't really defined this either. So we need to know what our rendering rectangle is, our FOV, our near clip, our far clip. FOV is really only matters for perspective, right? And then projection matrix type, and where we're going to store the viewport. So I suppose we could use like some default. Let's actually do a search for where viewport create is called. Because I think this is probably something that we didn't convert over. Oh, it's called here. Okay. So we create those. Create one for the shadow pass. Okay. And then we have viewport resize. All right, so it looks like we left the application. We left it up to the application to actually generate our viewports. So we need a way to say, okay, now we need to reach out to the render graph node and set that viewport. So this is something that we have not actually addressed yet. Because now, as opposed to us creating our render graph in code, we create it by configuration. So do we have, let's see. At this point, let me think, do we have, any sort of getter for this by name? Because that's really what we would need. We don't have anything like that. Okay, so what we need a way to call, where was it? Down here, I think. We actually have a lot of different things here we need the ability to call. Set render data, set viewport matrices. So this is actually going to be the guy that we have to call. So I think application update, application render frame, was it here that we had to do this? Render graph, execute frame, forward graph, here it is. So we have the forward graph. Would that be a prepare frame thing? I think it would be. So we have, let's do forward graph rather. And I guess we could just do a quick search here, a naive search. That kind of sucks, but do we have, yeah, we have a node count. All right, so I'm gonna first put a fix me in here. Cache this instead of looking up every frame. just to make sure that what I'm actually thinking is going to work, I'm going to do this the stupid and naive way. So we're going to say u32 node count equals that, and then we'll do for u32 I equals 0, I is less than node count plus I, and then if strings equal I guess I'll say. And we're going to do state forward graph nodes sub I name. We're going to compare that against, let's see, which one do we need here? We need the SU, what did I call it? Oh, SUI, perfect. All right. So if that equals that, then we have the one, right? So I can just actually take this, cut that, right? Oh, I didn't want to do all of that. I want to do that, and I want the address of it. Now I can say node name, and then we can do UI render graph node set viewport. Really? So viewport and matrices. Bam, there we go. All right, so self is going to be node, right? And then we just set the viewport and the projection and all that stuff. So the viewport is going to be UI viewport is what we're going to want to use for that. The view matrix is going to be state was it UI viewports. Oh, I think we actually want UI viewports. Let me think about this. Oh, the view was actually, in this case, mat for identity. And then projection was, oops, state UI viewport projection. Is that right? That seems right. Okay. So we set that there. Now, this is obviously terrible, right? We don't want to be doing this like every frame, right? Which is why I put this here. But just to make sure that it actually works and I'm thinking this through correctly, that's what I'm going to do. And I put a big giant fixby there so I can slap myself into fixing it later. I suppose I could also like do like a no check-in thing like that as well. Okay, so let's build this. Undefined reference to UI render graph node set viewport and matrices. Did I not export that? UI render graph node. Ah, okay. So somebody was asking about KAPI earlier. So because I didn't actually export this function right here, it's unable to be linked, right? Because it doesn't have public visibility. So I have to put this KAPI there. I'm just going to go ahead and expose these as well, right? And now when I build it, it works. Why use NeoVim instead of NetVim? Because the configuration is a lot easier to use. And also, unfortunately, the creator of Vim passed away. So I don't really know where that project's going to wind up. So yeah, it's just kind of where I landed on that. NeoVim is fine for most of what I need. The plugins for it are generally pretty good too. There are some plugins that I'm using that aren't available for Vim. And then also, the only other thing I can really add to that is I am working on my own editor behind the scenes, but it's not really ready for prime time yet. So eventually I'm going to be switching away from this to my own editor, but I'm not there yet. Let's see. Do you use Arch, by the way? Yes, I do. Yep. Switch to dual booting with Linux Mint. Love it so far. Yep. Yeah, so I use, I'm dual booting Windows 11 and Arch at the moment. Use Arch with Hyperland. I actually used that for quite a while on stream, and I used it for a decent amount of time, and I liked it quite a lot. The only issue that I ran into was Wayland issues, unfortunately, right? Not a whole heck of a lot to do about that, but yeah, I just, you can't run render doc on it, for example. And there's just other issues with it, so I eventually had to switch away with it. Let's see. When you have time, can you check out the Rendering Engine Architecture channel? They have some interesting ideas from Infinity Ward and Remedy Games and a small talk from 4A Games. Okay. I will. Oh, I think I've seen this channel before. I'm actually subscribed to it. Yeah, it's been a bit since I've had a chance to watch the content on there, but yeah, that's a really good channel. For those of you who are wondering what the heck I'm talking about over on the YouTube side, that is the channel we're discussing at the moment. Diamond, good to see you. How are you doing? What would your own editor have that NeoVim does not provide? Couple things. I can make it work the way that I want it to work. And I can also not have to worry about like updates to it, just breaking the entire freaking thing, right? So like one of the problems that I have with NeoVim is because I'm using a decent amount of plugins for some stuff, if you update your plugins, you update NeoVim, you update any of it, stuff tends to break a lot, which is really annoying. And it's usually pretty stable, but every once in a while it becomes unusable, which is definitely not great, right? And so what I'm doing is I'm building my own editor that is basically going to come already packaged the way that I want it to, already configured the way that I want it to. I thought about branching Vim itself or NeoVim itself, but I was just like, I don't really need everything that it does either. So yeah, I'm just kind of in the process of writing that. So for those of you who have heard of, memes about something called Notepad ++, that's actually what it's called. Because you have Notepad++ out there, right? But Notepad --, it's now a thing. It's just not public yet. You're currently in Denver and forgot your computer? That sucks. All right, so did we built successfully. Let's run and see where we got. Okay, I don't think I need that anymore. Let's disable that breakpoint. Okay, so now we're seg faulting. That's cool. All right. Color targets. All right, so I'm guessing we are past junk data here. Yeah, that's rubbish. Okay, and we don't have a depth buffer. Okay, so what did we... color target count is 1. So it looks like we were past a junk array for that for some reason. All right, so let's see. This is the UI system again. Oh, we made it a whole 2 lines further, folks. Isn't that awesome? All right, so here we are taking the internal data color buffer texture, which is nothing, right? Am I understanding that correctly? Yeah. That's interesting that that didn't actually segfault at that point. So we're taking the address of internal data, color buffer texture, renderer texture handle. How that's not segfaulting even trying to do that when this is null is a little bit beyond me. That's... okay. I think I know what that is too, because I don't think we're actually we're not like resolving this color buffer texture anywhere. I don't think. Do we actually do this? Yes, we do. Okay, so we have a bound source. So self syncs 0 configured source name. So okay. So our bound source is going to come from debug color buffer. Oops. What did I do? Here we go. It's a texture. It is bound. Here's our color buffer. But we have a null pointer there. Okay, so likely we're probably just not passing through our color buffer texture, which I actually question if we're even doing that from the top of the render graph at this point correctly, because we haven't exercised that code yet. All right. DelCX, thank you for the follow. Pocket Watch, thank you for the raid of 24 viewers. How are you doing? What did you get up to on stream tonight? You're gonna raid and run, working on Monaco too. So if you guys haven't, if you guys have not seen Pocket Watch's channel, he's working on a really excellent looking game called Monaco 2. And I really just love the visual style of the game. It looks really super clean, and I just love the visual style of it. It looks like a really cool game. So I highly encourage you to give him a follow, because it's a really interesting stream to watch. I lurk in there all the time, but yeah, very, very cool stuff. So highly encourage you guys to go check him out. Sleepy Mushroom, how's it going? Good to see you. Yeah, no problem, Pocket Watch. And thank you again for the raid. Have a good one. All right. So for those of you who are new to what we're doing here, I will pull this down really quickly. So we are building a game engine from scratch using C and then Vulkan as our initial rendering backend. So I say initial rendering backend because we are going to have support for Direct 3D as well as Metal for backends. But right now we're just starting with Vulkan to get things started. It started off as a YouTube tutorial series, and then it changed formats a couple of times because we kind of outgrew that tutorial format. We wound up streaming live here on Twitch. And it looks like we're going to have ads here in a second, unfortunately. So I'm going to try and make this as quick as possible. But basically, we are a completely open source and free engine. So it is Apache 2.0 license, which basically says if you want to use it, all you have to do is say that you're using it, and that's it. It doesn't matter whether it's for personal or commercial use. There will never be any royalty fees or licensing fees of any kind. It is cross-platform, so it is on Windows, Linux, and Mac OS desktops right now. with other platforms planned for the near future, such as mobile. And then I'll go ahead and drop a link in chat for those of you that are interested. That's to this website here, which is sort of the central hub to it. It's got links to like the Discord, which has got about 900 people on it, and the GitHub, which has all of the source code, right? So it is, as I mentioned, completely free and open source there. And we have ads. So I'll have to finish my my introduction once we come back from ads. For those of you who can still hear me, we do break for ads. We do stop the stream for ads, so that way nobody misses content. Just because, you know, it kind of sucks if something's being explained and you can't actually see what's going on the screen. So I usually recommend that you use this time to like hydrate or, you know, get up, stretch, something. So we got about a little under 50 seconds left on ads, and then we will be back at it. About 30 seconds left. 20 seconds, rather. All right, and ads are dead. Cool. So, for those of you who weren't able to hear me during the ad break, we do pause the stream when ads come up. That is once every 30 seconds. Once every 30 minutes for up to 90 seconds on Twitch. So we do synchronize our YouTube and Twitch ads as much as possible. But whenever those come up, I do pause the stream just because, you know, those ads are full screen and you can't see or hear what's going on, which for a programming stream, that kind of sucks, right? So the last part of the sort of intro spiel is we do have some basic PBR pipelines set up, right? Some cascading shadow maps, you know, just basic stuff. And, you know, this is kind of what the engine looks like at the moment. I'm unable to run it because we are in the middle of a fairly large refactor, or I should say nearing the end, actually, of a fairly large refactor, to eliminate a lot of tech debt that was in the engine. So, you know, it's starting off as a tutorial series. We kind of built up some tech debt from the very beginning, just because of the way you have to kind of structure that stuff. And we are going through and eliminating a lot of that in this large refactor. So here are some screenshots of what the engine looks like. Hopefully we'll have it up and running soon so that I can demo it again. But for right now, I'm unable to do so. So I hope that makes sense. Welcome, Raiders. And we're going to crack on with our debugging, right? So right now what we're doing is one of our large refactor efforts was within the render graph. So we are debugging our render graph in general just to kind of get a feel for how that is working. And, you know, we've got some issues that we're just kind of fixing as we find them. So I think what we need to do is we need to actually look at when we have render graph create. When we have render graph create, are we actually passing through our global depth and color buffers? A majority of this code is completely unexercised, by the way. So we're kind of just figuring out what does and does not work. Okay, so all right, so we do have a global color buffer. It looks like width and height on that are 0. Array size, no, this is all 0. Okay, what about the depth buffer? That's all 0 as well. We do have a render texture handle. Do we have? So we have internal resources. We have our Vulkan resources. Okay, so I think what we're just doing here is we're not actually setting these correctly. So let's see why that might be. So we're setting up the render graph. This is application initialized. So this would happen after we already have our first window set up. So I guess we're just not, yeah, active window get. And then we create based on that window, which is here. So those resources are passed into the render graph when we first create it. So that's good. So our error checking here is good. So I think the next thing that we need to do is debug through our source, our sinks and source linkages for all of our nodes, and make sure that we're actually getting the sources as we're supposed to. So let's see. Let's just take a look really quickly at the application config. All right, so the way this is supposed to work is frame begin doesn't really do anything in terms of Vulkan, but it kind of gives us an entry point into the frame if we need it, right? So if we need to like prepare something for the frame as far as the render graph is concerned, that kind of allows us to do that. So this one's fairly light. Clear color and clear depth stencil are the next things to get those attachments. So the way that this one works is we get frame begin color buffer and frame begin depth buffer. So let's take a look at the frame begin node. Right, so we have our two sources that we have here. So one's called color buffer, one's called depth buffer. That is what these two guys reference, right? So our clear color references frame begin color buffer. And then our clear depth stencil is frame begin depth buffer, which is here. We do set the color buffer source. We set the texture of that to the global color buffer. Okay, so this sets the global depth and color buffer correctly. So at this point, this node is correct. So what we need to do then, and that's actually during creation of that, which is probably that probably should technically be like an initialize or something, but I think it's fine. We should probably look at the clear color. Right, so here's the color buffer sync. So the color buffer sync is, oh, wait a minute. Did we? Are we manually handling this? Configured source name. Type config source name. Okay, so we are actually pulling this out of just the type config. All right, that's fine then. So the way that this should work is when we go to load resources, here's where that's done. So internal data buffer texture, which is just a pointer to a texture, is self syncs 0 bound source value t. Okay, so that's half of the battle. Oh, that's not going to work actually, because our color buffer sync up here, for example, right? Our bound source is 0. Right? Our bound source, there is no bound source. Right? But then we're saying here, let's grab the bound source. Okay, so we probably need to debug that. So let's go to the clear color node. Let's kill this. And I'm actually just going to skip right to this part right here. I just want to see what's actually being saved here. See if that's actually valid. We know that's good. We can get rid of that. Okay, so self syncs 0, which is the color buffer. Bound source. So we do have bound source. So our linkage worked. Right, and our value texture is not set though. Okay, so why would that be? That's where the null pointer is coming from. So really, I guess the begin frame isn't doing something correct. Color buffer source. Okay, so like, I guess let's set a breakpoint here, right? Or I guess I'll set it here. Okay, so this is the begin node, right? So that's this guy. So color buffer source. We don't have a texture. Graph global color buffer is, wait a minute, didn't we? Am I going nuts? Didn't we verify that that was set? Did we not? Global depth buffer. Oh, wait a minute. Did we not actually set it? We didn't set it in the graph. Oh, what a dingus. Okay. More dingus-oriented programming. All right, so... So right after we verify this, I could have swore that we... Okay. That is where we have to set that. So I guess right after we verify that, we'll say outgraph global depth buffer equals global depth buffer. Outgraph global color buffer equals global color buffer. Right. So now let's see. I guess let's get rid of that. Do we have source value? Hey, texture is there. All right, perfect. Let's check this one too. Oops. There we go. We got texture. Okay. Tends to help when you actually like do something with the input parameters, right? Okay, so we should have self syncs bound source value. Hey, now we have a texture here. Sweet. All right, so we know that one's good. So let's continue. And then this is the load resources for the UI render graph. So let's just see self syncs bound source value. Okay, so this one does not for the UI render graph node. Okay, so this one does not. So this is not resolving correctly, so we'll have to figure that out. Need more asserts, clearly. Yeah, probably. Does khandle reference object pools or something? So khandle is well, it does two things. So a khandle is first off, is a index into a resource array of any kind of resource, right? So we have systems that are set up to use khandles, and one of the properties of a khandle is its handle index, right, or its resource index. So that's just usually an index into an array. And then we also have a unique identifier that is, you can think of it sort of like as like a generation, right? And it's a randomly generated 64-bit int that is used to determine whether or not that handle is actually stale. So whenever a resource is updated, such as freed at that index, that resource index, whenever we free one, we change that identifier internal in that system. And then we say, okay, hey system, is the index or the ID that you have it at this index, does that match the one that's on this handle? And if no, then we say we have a stale handle, and we throw an error or something. So Zaka 6, I appreciate that. Taman, how's it going? Good to see you. Welcome. Hope you're doing well. Is there any plan to support FreeBSD eventually? Yep. That'd be neat. Let's see. How do you have those save lines on VS Code? Waiting on something other than refactoring. Never going to happen. Yeah, no, we're actually done refactoring at the moment. This is actually just debugging through our refactoring and just fixing bugs. The refactor itself is technically already done. Okay, so this is going to be a problem. So our bound source for our, let's see, what sync is this? So our color buffer says it's getting from debug color buffer. So we're looking at this guy right now, right? So it has a sync called color buffer, and its source is debug color buffer. Debug has a source called color buffer, right? And its sync, or its sort of input, you can think of it as, is forward color buffer, right? Which means it takes the output of this and uses that. So debug, okay, so color buffer, this pulls from skybox color buffer, and then skybox color buffer pulls from clear color color buffer. So we know that clear color color buffer is good to go. After that, we don't know that. So I guess we need to look at skybox next. I'm betting we've got some sort of skullduggery afoot here. Okay, so our sync config, the color buffer sync, here we have that. Bound source is 0, right? And then when we come down further, here's the color buffer source, right? So we have nothing there either. So we initialize, that's fine. Load resources, okay. So our bound source, if we have that, then we say the internal data color buffer texture is set to this. But. So we take the value from the sync, but we never set it in the source. That's the problem. And I'll bet we're doing that like all over the place. All right, so we have this. What we also need to do is do self sources 0, since we know we only have one. And then we'll go, let's see, value t equals internal data color buffer texture, right? And we can do self sources 0 is bound equals true. We need to come up with like some sort of interface to sort of kind of do this for us. That would be nice to have that automatically link. But I think for right now, I think I'm fine having the individual nodes do it. All right, so we know that will likely solve that problem. I guess let's build this real quick and verify that. So we'll do this. Right, and then we'll have sources value. We have the texture, okay? So that's the window color buffer texture. Perfect. So it's pulling that reference all the way through. So we just really need to make sure that we do the same thing. So we've done that for skybox. We need to do that for forward. Right, so let's see. So this one's a little more complicated. So let's see, let me actually look at so we have 2 sources on this one. We have the color buffer source and the, the depth buffer source, right? So when we go to, do we want to do this during initialization? No. Load resources, here we go. Okay, so it looks like we did a quarter of the work that we should be doing. Sweet. Okay, so we need to resolve the source for the color buffer, but also for the depth buffer, because that is technically, that could be used elsewhere, right? So we do need, we actually need this. Whoops. Oh, and that's returning. Nice. That shouldn't be doing that. Then we need this, which this probably needs refactoring too, because hello magic numbers. But I just want to get it working for now. You can always make it flexible afterwards. Okay, so we want to use depth buffer texture there, depth buffer texture there. Okay, so that outputs to that. Then debug 3D. Looks like it only makes use of the color buffer, so I'm actually just going to take this. Let's do here. Yep, same thing. All right, so we've got that. And then, let's see, we need the standard UI one. This one. So that one's going to be up a little bit. That's the execute load resources. Here we go. So we need that right here. All right, so that's the standard UI one, and then frame end. Frame end is what actually performs the presentation. It looks like we've got some work to do in here too. Okay, so if this, let's see. Load resources, no resources to load. That's true because we don't have a source that we need to set up. That might be true. We might still need to do this. All right, I'm going to build this for now and see where we get. All right, let's run. Oh, wait a minute. Right, okay, so that looks fine. All right, cool. So looks like we've got require shadow map source, not hooked to forward pass. Creation fails. Okay. All right, well, that's pretty explicit, right? So let's actually take that. Find that error. All right, so we don't have shadow map source. Wait. That's render graphs. Okay. So how would that actually be? Let's see. So for this guy, we should be taking shadow, which is here. And we want to take the shadow map source for that. I don't see where we actually even set up. Wow, do we even set up our... So we have sinks. I bet we didn't do any of this because we don't actually have configured source name. Okay, we don't need a source for the shadow map. But where would the sinks bound source? Wouldn't that mean yeah, we're not even looking at this sink here. So that's, I'm not sure why we were looking at this. This really should be something like this, right? So we need index 2 for this. Shadow map. That's not the actual texture though. Shadow map source. I think we actually just need to do this. and this should be sinks sub2. Dang, Tammin, you hit a 30 stream streak? That's awesome. The cursor blink is killing you in VS. Yeah, I'm not really a fan of it either. I much prefer a solid cursor, actually. I'm sure there's like a stupid setting for that, but let's see. How do you identify which system it is a handle of? Is that an enum? So we actually don't. We rely on whatever is actually using that handle to know that information, right? So let me actually show you literally. This is literally all a handle it. Whoops. This is literally all a handle is. So it's an index into an array and a unique ID, which is basically just a 64-bit number that's used as generation. It is up to the system and up to the thing that is storing the handle to know what system to interact with, right? So if we have an X form, right, then we know that any handle that's called like X form handle or something like that, we know that that's a handle that goes with that system. And by doing that, it allows us to create however many systems we want. We don't have to have a system registry where we like maintain handle types or handle indices or any of that kind of stuff, right? We just kind of leave that up to the consumer of it to know that, you know, this handle goes with this system over here. And that's pretty much up to like naming the variable the right thing, right? So like a texture handle you would use that with the texture system. Even though that's an example of a system we haven't converted over yet, but you kind of get the idea, I think. Okay. So did I build this? I think I did. All right. Let's go ahead and run. Cool. I think we got further. All right. So now we have the correct color texture. All right. So I think let me just kill this breakpoint and continue. All right. So it looks like now let me guess. Yep, null array. Okay. All right, so this is in the execution of the render graph node. Internal render data renderables is an empty D array. Okay, so let's jump back to the UI render graph node and have a look at what that's doing. So let's see, execute. Ricardo Bosson, thank you for the follow. Appreciate that. Welcome. All right, so let's do 8. What was that? What line number was that? 169. All right, so we're trying to get a renderable count here from an array that doesn't exist. All right, so let's just quickly review what we're doing. So we are doing UI render graph node execute. Okay. So at this point, we should have grabbed all of the data that we need to be able to render all of the standard UI controls that we need to render. And the fact that we have this internal data renderables being null tells me we've not done that. So if we do, I think the way this is, yeah, so we have a set render data here, which I can almost guarantee is not being called, which is probably going to have to be done by the application, right around where we do set viewport and matrices. So let's take a look at testbed main. UI render graph. Okay. So in prepare frame, that's probably where we want to set that data. Let's see, are we doing any sort of, where are we gathering that data? I don't remember. It's been a while since I've looked at this code. Where are we doing? So this is all of the initialization. What about the so the standard UI system actually has a render on it. Standard UI render data. But I think render prepare let me go to text box. So this was done in the render function. So the render function is what generates the renderables list. Okay. And so that is going to be called are we actually calling that is the next question, actually. So that's going to be standard UI system render. Standard UI system render. Our old render graph was doing it for us. So we need to frame prepare. Okay, so we essentially need to grab I'm going to grab this whole thing, actually. This is like the old way of doing it, but we need to actually update this with the new way of doing it. So more or less, we have to make this stuff work the new way. So we don't have this UI path extended data anymore, right? This is where we're setting like the view matrix, projection matrix. Like this is actually all done by this. So actually this first part we can remove. We don't need this. Actually, what was current viewport projection? View matrix. Okay, yeah. Yeah, we don't need this stuff. Okay, so that's that. You can also get rid of the scoping, get rid of this. All right. And so what we really need is UI render graph node. Set render data. All right, so this is going to be node. And then the render data is actually just going to be like a local object that we set up. So let's do standard UI render data, right? Start that off that way. But then before we do this, we need to put that here. And we need to set render data renderables. We're going to use our frame allocator to allocate this, right? Because we have to create this collection every frame. So we're going to use our frame allocator, which is a linear allocator, to have as little overhead as possible during that allocation, right? So we're going to use that. And then before we set that, we actually need to do this. Let's see. So we need to get the state, which is no longer done this way either. Let's see. We did cache it. So this needs to be state SUI state. Let's see, what is that second parameter? The root. So null is going to say, just use the root of the entire SUI system. And then our render data is just going to be the address of render data. Okay, so we have that, and then all we do is pass render data, and we should be good. Speaking of which, don't these return booleans? Nope, that one's void. That one's void. Okay. All right, so gather SUI render data. All right. The other cool thing about using our linear allocator or frame allocator is we don't have to free this, right? Because it just is essentially a sliding pointer, and that sliding pointer gets reset to 0 every frame, right? So it's data that only lasts for that frame. Saw the clip where a guy asked if the first Game Boy was programmed in C in the Tetris movie. And thought of you explain not doing C++. Yeah, that's funny. When did Xform become an alternative to transforms? So technically, it's the replacement for transforms. It's a system that works differently, and so the reason we have both right now is because I haven't transferred everything from using the old system to the new system. So I had to name it something different. So I called it Xforms for now. And then what we're going to do is once we have all of the systems transferred over to use Xforms instead of transforms, we're going to nuke the old transforms, and then we're going to rename Xform back to transform, and then there won't be a difference. Hope that makes sense. All right, let's build and run. Okay. Descriptor set update and bind. Segfault. Fun. All right, we're passing a null texture map. Sweet. UI again. Boy, our UI system seems to be the most broken out of all of them. All right, so Atlas is empty. So that's interesting. So so the whole point of this is our UI system right now currently uses a texture atlas for all of its different UI elements. So that texture atlas looks something like, just as a review, because I know it's been a long time since we've touched some of this stuff. So if I come down here, let me collapse some of these. Right, so we have testbed assets. We come in here and do textures. That's already open. And we do, I think it was SUI or standard UI atlas. Here it is. Right. So this is like what we use to render our UI controls right now. Right. It's just a simple atlas. And so what we basically say is we allow renderables or these individual elements to override that atlas with their own texture if they have one. And so we basically say, well, if there's an atlas override, use that. Otherwise, fall back to our default UI atlas. So in this case, our renderable does not have an override, which means it should be falling back to internal data UI atlas. But internal data UI atlas, 0. Fantastic. Okay, why is that? I'm guessing that's because we haven't actually set that. I'm guessing. Right, so yep, there's set atlas right there. Okay, so we obviously haven't done that. UI atlas. So our standard UI system, that's available in the standard UI state. So I guess we just literally never actually set that at any point. All right, so I guess we need to go to, whoops, here. And before we actually do any of this stuff, let's just do UI render graph node set atlas. So that's going to be node, and then we need state, SUI state, UI atlas. Let's see. Oh, okay, address of. Okie doke. Sweet. All right. Update descriptor sets. So internal Vulkan swapchain image 0. Object type image. Update descriptor sets. P descriptor writes. Sub 1 image info was created with VK image usage color attachment bit, but the descriptor type is VK descriptor combined image sampler. If descriptor type is sampled image or combined image sampler, the image view member of each element of P image info must have been created with VK image usage sampled bit set. So that's our... Why would our Vulkan swap chain images not be created with the right? What? Let me think about this for a second. So this is complaining about or internal Vulkan swapchain images. We don't create that. The swapchain does. I bet that's just, yeah, it's the same thing created, bleated about over and over again. Oh wait, we do create the view though. We do create the view. It's not bleating about the image, it's bleating about the view, I think. The image view member. Yes. Okay, it's the view that we're actually screwing up. Okay, so the view needs to have this guy. I don't remember changing that, but okay. UI is the most broken in anything I do. Yeah, I feel that. Feel that to my core. How is this new transform system better? So it doesn't use pointers when building a transform tree. It uses handles for everything, which means that you can technically your instead of having like raw pointers to everything, which could have a null pointer, which could be bad, it allows us to have a hierarchy that doesn't necessarily have a transform coupled to it. So what I mean by that is, and you'll see this in game engines like Unity, where you have, let's say, an empty game object that you really want to just use as like a folder, right? And it's something that doesn't really make sense to have a transform. So it might be something like an empty node, or like a 2D audio emitter, or maybe you have something in the world like a skybox, right? A skybox doesn't really have a transform. It doesn't need one. Skybox transform doesn't make any sense, right? And so that is an object that can exist in the scene, right? And have technically objects parented or childed, parented or as children of it, right? But it doesn't have to actually have a transform to do that. So we actually separated out our transforms from our hierarchy. So those are two completely separate views now, so that we can have transform hierarchy if we want it and if we need it. But if we don't, we can still have a hierarchy of objects without having that in between. And you can actually have like root object that does have a transform, and then an object underneath of it that doesn't have a transform, but then an object underneath that does have a transform, and it'll actually reach up and around and go get the root transform as far up the chain as it can. So you don't have this sort of tight coupling or tight requirement of always having to have a transform for everything that's in the world, because it doesn't always make sense. So in separating those two out, it really didn't make sense to have like parent and children transforms anymore, because you don't really necessarily always have that. So now it's just that everything's controlled by handles, right? And so if it has a transform, if you have a node in the scene that has a transform, it'll have a valid handle. Otherwise, it won't have a handle to a valid transform. It'll just have an invalid handle, in which case you say, okay, well, this doesn't have a transform. I hope that makes sense. Okay. So I guess let's go to the swap chain and go into our, that's going to be create. And let's find where we're creating our views. Here's where the swap chain's created. Here's where we get the images. Okay, so render texture resources acquire is done on on the color buffer of the internal window, which the color buffer of the internal window is let me think about this for a second. Swap chain image count, swap chain images. Are we not? I might have foobarred this. Okay. All right, so basically what this does, what this is supposed to do anyways, we now have a window internal color buffer, right, which is nothing more than a texture, right? That texture backend data, the renderer backend data, is this texture internal data. This guy has a image count and array of images, right? And basically the way this works is if an image is created with this texture flag renderer buffering, then what happens is under the hood, we create one of those Vulkan images per frame in flight. Or no, not per frame in flight, per swap chain image, rather. So in most cases, that would be 3 if you're using triple buffering, right? So that should automatically be happening here, but then we're doing it again down here, which is a little bit... We're doing this again here. So I'm not sure that this is right, because we recently redid this. And then we loop through each one of these and create a view for it. And I think this is actually, well, this right here is what actually needs. Where was it in this error message here? We need... must be created with sample bit. Right, so we need... Really? There we go. So that's what it's bleating about, but I question this section up here actually, because I'm pretty sure that this should be handling that. So we do need a texture handle for it, right? So this is what fills out the render texture handle. This is an example of that, which gives us that lookup ability, right? So we have that. KB Dev, thank you for the follow. But I thought it also reached into the back end and created this stuff too. So I'm actually going to debug this because I think we're doubling our efforts here unnecessarily. So let's go to swap chain. We're going to go to, I don't know, like line 200. Right? And this is the section I want to go to here. All right, so we're creating our swap chain. So let's do that. Okay. We are going to have an invalid handle here, I'm pretty sure. Yeah, so we have an invalid ID here, and that looks like an invalid ID there. Okay, so it is an invalid ID. So the next thing that we do is we do render texture resources acquire, right? Which I'm thinking should create our views and stuff for us. Thank you for the hydrate redeem, by the way. 1016, thank you for the follow. All right. So window color buffer texture, swap chain extent. We have that. All of our texture flags. Okay, so let's actually just proceed through this. Yeah, we don't have the textures array yet, so that actually does make sense. We set that up. Then we have ads. So we're just going to pause the stream real quick while ads are running, and then we'll be back. A little under a minute left. "30 seconds, and then we can continue. All right. Ads are dead. So, what we do here is we create a new allocation for our internal data. And if the flags say that the texture is wrapped, we say true. Success is true, rather. Instead of okay. All right, that's why we're not doing it. Okay, so what I thought was happening is not happening. So ordinarily this texture resources acquire would actually be responsible for going in and actually creating the Vulkan images, creating the views and that stuff. We're not doing that here because we are going to do it manually in the swap chain, because the swap chain provides us those images. And because the swap chain provides us those images, we don't need to create them, but we do need to create the views for them, which we don't have separated out in the back end. So all of that to say, we insert the lookup into the array because it was successful, set the out handle, return success, and now we have a renderer texture handle that contains like actual handle stuff. All right. Okay, so texture internal data. So we go ahead and get a pointer to that. That should be empty, which makes sense, right? Because we created that on the renderer front end, but we didn't actually fill it out. So we create that, or we get that rather. Let's see. Name is meaningless here, but might be useful for debugging. Sure. Okay. So image count, swap chain image count, that's 3. We don't have images, correct? Yeah. So we go ahead and allocate that times the image count. So that's correct. Then we set parameters for each. So we loop through the images. We get the address of images sub I. We set the texture name, right? So internal Vulkan swap chain image 0. Let's see, doesn't apply anyway, is not needed. Memory flags. That's true because we don't control the image. We don't reallocate it or anything on resize. So that's true. We have one MIP map level. We use the swap chain image format. We have one layer. And we do not use layer views because it's not a layered image. It's just one layer. All right, so we do that for all three. Right, so we do that. Then we go ahead and we set up a view for each image. So we get the handle, width, height, format, blah, blah, blah. Just, okay, I think this is probably going to fix the issue. I don't know why. I don't know why it was bleating about this not being here, because I don't believe I had to require that before. Jumping Nato, thank you for the follow. Appreciate that. Out of curiosity, why so many swap chain images? So it's for triple buffering, right? So more or less the way that works is you have these three images that are in a pool, right? Out of those three images, typically speaking, you're going to have one that's being presented, right? And while that image is actually being presented, you're going to be drawing another image, drawing to another image, writing to another image, right? And theoretically, you could be also writing to a second image at the same time, right? So you technically can have two images in flight at the same time being written to while the third one is being presented. And so that's what triple buffering is, right? Is you can be rendering two more frames, right? So you can be presenting frame 0, let's say, and then be drawing to frame 1 and frame 2 at the same time, right? Or slightly offset from one another. And then you'll present frame 1. Frame 0 will go back into that pool to be drawn to. And then you'll present frame 2, and then frame 1 will go back into that pool, and so forth. It just kind of continues. Let's see. Oh, I thought I saw you had 32. Never mind. Oh, okay. So the 32 you saw was it out here or was it in? Oh, where was that? There it is. You're talking about this. So the reason I did this is because this way I don't have to dynamically allocate an array of these swap chain images, no matter how many of these swap chain images this actually gives me, right? So ordinarily the way you would do it, right, is you would say, okay, I want a count of swap chain images, right? So that's what this returns when you don't give it any memory. Here is the last parameter, right? So it basically fills out this image count saying, this is how many we need. And then what you would do is you could dynamically allocate an array of swap chain images, and then you'd pass that over here, right, as the last parameter. And what we're doing here instead, and technically I don't need to make two calls for this. In fact, I could probably get rid of one. What we're doing here is 32 is the max number of swap chain images we could ever get, right? According to the spec, it'll never be more than 32. And so this is a small enough struct, right? Where I just created a flat array of 32 of them and say, okay, fill out however many you have here, right? And since this is on the stack, it just gets thrown away when it goes out of scope because it doesn't really matter, right? We take the ones out of here that we need, throw away the rest. Yeah, so I hope that makes sense. Usually just done double buffering. Yeah, okay, yeah, so we're doing triple buffering here, so that's why we've done it that way. Kuju raided with a party of 17 viewers. Thank you so much for the raid. How are you doing tonight? How's your game coming along? If you guys are not familiar with Kuju, definitely go follow him because he is making a game called Fat Goblins, which is super freaking sweet looking. And he's making it in Jai. And it's over on Steam, so I highly recommend you guys wishlist it. Help him out. I don't have the link handy, unfortunately, but yeah, it's a really sweet looking game. So definitely go check out his channel. Give him a follow. Character controller actually works. Sweet. Dip real fast, but hope you have a good stream. I appreciate that. I do appreciate the raid. Thank you. Pale Blue Zebra, hello. How's it going? Implemented a custom character controller by modifying contacts of a dynamic rigid body in like 50 lines of code versus the physics character controller barely functioning with 2,000 lines of code. That sounds awesome. That's your whole rant. Fair enough. Oh, I kind of am sorry I missed that, actually. That sounds really cool. The fact that you did it in 50 lines of code is pretty freaking sweet, right? Yeah, that's really cool. Okay. I'll have to watch the VOD on that. That's really neat. At some point, I'm going to be probably using physics in this engine as well. So it's incredibly frustrating since I spent like 12 hours yesterday alone trying to get the default one working without bugs. Oof, yeah. That's one of the bad things about libraries, right? Is like when you have stupid stuff like that just doesn't work. But yeah, have a good one, Cujo. It's good to see you again, and thank you again for the raid. I appreciate it. So for you, those of you who are new here, we are creating a game engine in C using Vulkan as our initial rendering backend. So just as a quick recap of what that is, it's a game engine series that we're building. We started off as a YouTube tutorial series that changed formats as the series progressed, kind of outgrew the tutorial format, landed on a live stream format. And that's what we do now. It is open source and free. So it is 100% free and open source. It's available here on GitHub, and it is Apache 2.0 license, which basically means commercial or independent, you can use it for whatever you want. All I ask is that you mention that you used it. There will never be any sort of licensing fees or royalties of any kind ever. It will always be free. And we have links here at the kohiengine.com website, which is sort of the central hub for the whole project, to like our Discord, our GitHub, Patreon, YouTube, Twitch, all that good stuff. So all of that's there, including the stream all the way at the bottom, so I can sort of wave to myself, say hi. And there it is, Inception, yay. And yeah, so this is cross-platform, so it works on Windows, Linux, and Mac OS desktop platforms, with more platforms to be included in the future. I say Vulkan as our initial rendering backend because we do have plans to support Direct3D and Metal as well. So eventually we are going to write rendering backends for those as well. So right now we are in the middle of a fairly large refactor effort. I shouldn't say in the middle anymore. We're actually at the end of that, and we're debugging all the bugs that sort of got introduced as part of that. So we're eliminating technical debt, solving bugs, and that's kind of where we're at. So we're just debugging some issues with swapchain images right now. I think I've actually probably solved the issue that we were looking at, and that's just kind of where we are at. Let me make sure that I built this. Pretty sure I did, and I'll run again and see what kind of issue we hit. All right, I'm going to go ahead and kill this breakpoint for now. All right, I saw something in there. Saw something fly by. Okay. So, validation error. Okay, that was fun, but I saw something further up the chain here. I could have swore. Yes, that's what I thought. All right. VK create image view using format with aspect flag, color bit, and stencil bit. But color in. Why do we have stencil bit there? That's for the depth buffer. Did we mess something up when we were in here? I don't think so. It might be, though. Let's do... window created. I might have messed something up with the depth buffer when we're creating that, because I moved all this kind of stuff around. Depth bit, stencil bit. Okay, so that's the image creation. What about the view? Okay, what did this say? Oh, this is bleating about the swap chain image. So it was the swap chain. So I did foobar something in the swap chain. Okay. Aspect flags. Oh, wait a minute. Wait a minute. I think I know what I did wrong. I put the image usage here in the aspect, and that should be, well, not there. And now I don't remember what the initial other error said. So let's relaunch. Okay. So let me just make sure that that error went away up here. It did. Okay. So the thing that we were actually trying to solve. These error messages are fun from Vulkan. All right. So what did that say it wanted again? Okay, so if descriptor type is sampled image or combined image sampler, that's us. The image view member of each element of p image info must have been created with image usage sampled bit. So the view has to be created with the image view member of each element of p image. Okay. So we don't do that here. Oh, is it because wait a minute, why do we have it's saying the image has to be created with the image view member of each element of p image info. When we're creating or updating the descriptor set, it has to be. Wait a minute, though. We're not sampling this anywhere. So why? What is trying to use that as a. Oh, that's interesting. It's actually way deeper than I thought it was. So what that's actually telling me is we're trying to write to a descriptor set like we're trying to sample this. We're not, I don't think I'm sampling that anywhere though. Which makes sense, right? Like this would not be actually created with, the swap chain's not going to create it with VK image usage sampled bit, right? That actually makes sense, but where and why is it trying to sample our swap chain image? Okay, I think, thankfully, since that's not a, What on earth is trying to use? That's what I'm getting from that. All right, let me think. What would be trying to sample my swap chain image? That makes absolutely no sense. VK write descriptor set. Let's take this. Oops. And pretty sure there's only a couple places where this is actually done. And I think like it's done for UBOs right there. And then done for sampler descriptors here. So this right here is what it's bleating about. Something that's getting passed into descriptor set, update, and bind is just wrong. So when we go to I wonder if I can get, let me actually go to debug callback. Let's set this breakpoint there. Let's do it there instead. Relaunch. Might be able to trace it that way. Descriptor write count is 1. You know what? I'm not gonna. Let's kill that one. Okay, caught one of them anyway. All right, so this one is coming from the UI again. So what is the atlas here? Standard UI atlas. I wonder if our handles, oh, that's index 0. That's what's doing it. And that has a unique ID of 0 too. That's what's doing it. So handle index 0, I happen to know, is always going to be a swap chain image. So what this is doing is it's saying, okay, I'm reaching into the render backend and I'm getting handle index 0, which is going to be our swap chain image. So even though we're supposed to be pointing at something else, we're actually not. So standard UI atlas, where is that actually loaded? Is going to be the next question. Because I have a feeling that is just not doing what it's supposed to be doing. That's fun. I wonder how I could like detect that reliably and just like say, hey, stop trying to use swap chain images to sample from, you dingus. Let's see. I just saw your series on YouTube. That series is updated. You have plans to update it or not? Which series are you talking about? Are you talking about the Kohi Game Engine series? Because yeah, all of these wind up on there. Sometimes I do forget to update the playlist, which is probably exactly what's happened if I had to guess. That's probably why you're asking that. So like this playlist here has got, oh yeah, okay. Looks like I've got some things to add. But if you go directly to my channel, right, and you go to live, all the latest episodes are there. So I'll have to update the playlist, but yeah, all the latest episodes are here under live. So it is definitely up to date for sure. I mean, they're there. You just have to update the playlist, I guess. Tati Scarface, thank you for the follow. Appreciate that. All right. Does it support Linux? Yes, it does. I'm on Linux right now, actually. Yep. Arch, by the way. Okay. So I guess I need to go to standard UI system. And wherever we create the UI atlas, wait, where does that actually get? State UI atlas. Do we? Where are we actually creating that? Texture system acquire. Standard UI atlas. Is this broken? Oh, wait a minute. Is this? Process texture reference. Sure. Okay. Needs creation, true. Create texture. Skip load is false, right? Okay, so load texture, 2D texture, resource name, texture load params, I will bet anything that this is probably not doing what it needs to with the handle. Oh, interesting. It never even hit that. Never even hit that. Okay, why is that? Why did it not hit my breakpoint? Create. Load. So job create. Okay. So there's the parameter data. We take a copy of that. submit this to be done. All right, and then this texture load job start is what should be kicked off, but interestingly enough, never happened. Ads happened though. Team Arch, exactly. Yep. So we just got about minute left on ads. I meant to bat those away, but missed the timer. Almost done with ads. All right, cool. So our ads are just about done. And ads are dead. Perfect. All right. Yeah, Arch, by the way. Okay, so I'm going to have to get to the bottom of this issue, but we actually have made some pretty good progress tonight. That being said, unfortunately, I do have to get up in the morning for work, so I've really got to end the stream here tonight. That being said, we will be back tomorrow night, so if you guys haven't already, I would greatly appreciate a follow. Lucan, thank you for the follow, by the way. Appreciate that. But yeah, a follow / subscribe on YouTube / Twitch would be great. I really appreciate it. It helps me grow the channel, helps me reach more people. And I will be back tomorrow for another stream. Spiro, thanks. I appreciate you, buddy. By the way, for those of you who aren't following him, follow Spiro, because he is a genuine good dude. And he's another dev here who's always doing stuff, thinking outside the box here on Twitch. So definitely give him a follow. But let me see who I can raid. Okay, actually, there is somebody here who we have not raided before. So we're going to try a raid of Ryan Art, who is doing pixel art and C++ game dev. Tower defense strategy is what I'm seeing here, which sounds pretty sweet. So I'm going to start that. And yeah, thank you guys so much for being here. I really appreciate you guys. And we'll catch you on the next stream. And until then, peace. Have a good one. All right. Cheers.